Today we're looking at lesson 4.7 for geometry on congruence transformations. So I'm sure in math at some point you've looked at different transformations. We are looking at today a reflection, a translation, and a rotation. And when we're looking at congruence transformations, we're making sure that the transformation from the first shape to the image, which is the transformation shape, that those two shapes are also congruent. So we're going to be verifying that. The first shape is called the pre-image, and the new figure shape is called the image. When we're looking at transformations, the entire subject of transformations is called isometry. So here is the examples of a reflection, which sometimes you can use the word flip, or a translation, which is a slide, or a rotation, which is a turn, usually around an axis or a center point, which they call the center of rotation. So we're going to look at these three images, 1A, 1B, and 1C, and determine what type of transformations they are. So the first one, usually if it's a reflection, it's going to either reflect over the x-axis or the y-axis. So it looks like for 1A that it's reflecting over the x-axis. So we would say that this is a reflection. 1B, it looks like it's turning. So we're going to say it's a rotation. And for C, it looks like it is sliding, so we're going to say this is a translation. Now, I keep saying that it looks like. For transformations, you can definitely tell what type of transformation it is just by looking at it, but then when you're asked to verify the congruence of it, that's when you're going to need to do a little bit more work, maybe using the distance formula, which we'll do in example 3. The next problem has you look at two different pictures, real-life pictures, and also talk about what could be the congruence transformation here. So we're looking for either a flip, a slide, or a turn. So if you think about a door opening on a van, that is more like a slide. So we're going to say this is a translation. And then 2 footprints in the sand. Those look like they would be reflecting off of from each other, so this is the reflection. And then for the last example, it gives us vertices for triangles. You have the pre-image and then you have the image. So we're supposed to graph both of those figures, and then we're supposed to identify its transformation as well as verify the congruence of it. So we're going to first graph them. So we have -2, 2, -8, 5, and -4, 6. So -2, 2. -8, 5. Now you should probably use a piece of graph paper, but we're going to do this by looking at it. And then -4, 6. One more up. It's going to be a little bit up here. So if we connect those, we have our triangle here. And then we need to do triangle PQR. So 2, -2. And 8, -5. 4, negative 6. One more. I ran out of room here. It's down here. So if we connect to those, it looks like this could actually be a reflection across the origin, but we need to verify that it's a reflection. I actually think that they usually don't have a reflection across the origin, so this actually would probably more be appropriate to say that it's a rotation, like it's turning around the axis of the origin, kind of like this, in that direction. So I would actually say this is a rotation, not a reflection. The reflections would more so have to be on the same side of the graph, not diagonal like that. So then if we're going to try and say that this, or verify that this is a congruence transformation, we're going to need to say that all of the sides are still equal to each other. So we're going to have to use the distance formula to measure each side and prove that the triangles are also still congruent to each other. So what we're going to do now is we're going to find the distance formula, or use the distance formula to find the side lengths of each triangle to verify that they're congruent with each other. So we're going to go back to the points, and we have 3 sides each to find the distance for. So let's start with JK. Our points are negative 2, 2 and negative 8, 5. So using the distance formula, we're going to subtract the x's, square that, and add that to subtracting the y's, and square that. So we get negative 2 plus 8, which is 6. 6 squared is 36. 2 minus 5 is negative 3. Negative 3 squared is 9. So we get the square root of 45 for JK. Then the next line, or the next segment, KL, negative 8, 5 and negative 4, 6. That's going to give us negative 8 minus negative 4, square that, 5 minus 6, square that. So that gives us negative 8 plus 4 is negative 4. Negative 4 squared is 16. 5 minus 6 is negative 1. Negative 1 squared is 1. So we have the square root of 17. And then one more side for that triangle would be JL, so negative 2, 2 and negative 4, 6. That gives us negative 2 minus negative 4, square that, 2 minus 6, square that. So negative 2 plus 4 is 2. 2 squared is 4. 2 minus 6 is negative 4, so negative 4 squared is 16. So we have the square root of 20. So now we're verifying that to be congruent with the other triangle. So we'll do this again. So PQ for the other triangle, 2, negative 2, and 8, negative 5. That's going to give us 2 minus 8 squared plus negative 2 minus negative 5 squared. That becomes negative 6 squared, which is 36, plus negative 2 plus 5 is 3, so 3 squared is 9. That gives us square root of 45. That does match JK, so that's one set of matching sides. Then we have QR. That's 8, negative 5, 4, negative 6. We have 8 minus 4 squared plus negative 5 minus negative 6 squared. That's 4 squared, which is 16. And then negative 5 plus 6 is 1. So 1 squared is 1. That's the square root of 17. That matches KL. And then one more. RP. So 2, negative 2, 4, negative 6. And that gives us 2 minus 4 squared plus negative 2 minus 6 squared. So negative 2 squared is 4, plus negative 2 plus 6 is 4. So 4 squared is 16. That is the square root of 20. And that does match JL. So we've matched each side length to be congruent with the other side lengths. So we verified that this is a congruence transformation. And that concludes lesson 4-7.